Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 1444 that says number of ways of cutting a pizza. So here you are given a rectangular pizza represented as a row into columns matrix where a character A represented an apple and dot represent an empty cell. Further, you are given one integer k and you have to cut this pizza into k pieces by using k minus 1 cuts. So if you want to divide this pizza into 3 pieces, then you have to make 2 cuts. Okay. Further, for each cut, you choose one direction. See, here, let's say here, if you are given this type of matrix, and now for each cut, what you have to do, you have to choose some of the direction, whether vertical or horizontal. Means either you can cut a pizza like this way in a vertical direction or in the horizontal direction. Now, if you cut in a vertical direction, the left portion will be separated out, and you will be have this remaining right portion. Okay. Now if you cut in a horizontal way, that upper part would be one piece and the lower part would be another piece. Got it? And the condition that you have to satisfy, that whenever you cut a pizza either vertically or horizontally, this both means this part must have an apple, this must have an apple. Here also it must have an apple, this is an apple, here this it must have an apple. Got it? So yeah, and the last piece remaining would be given to a last person. Okay, the thing here is k is the number of person here, and you want to divide this pizza into all the given person, all the k person. For that you will make k minus 1 cuts, okay, to divide the pizza. Further, and what you have to return, you have to return the number of ways of cutting the pizza such that each piece contain at least one apple. See, this condition has to be satisfied. Okay, so here we need to return the number of ways, and if the with the modulo of this, so that we are inside the bound. Now guys, if you take a look at the first example here, see here this is the given matrix. Let me just draw you this. So this is the matrix. Okay, now here the k is 3, that means we have to make 2 cuts, and we need to find number of ways to make cuts such that each pieces has one apple. Okay, so let's say we make this as a first cut. So this is now separated out, and this is the remaining part. Okay, this is given to one person and this is the remaining. Now from this remaining we can make these cuts. Okay, so yeah, this is separated and the last person will get this piece. Got it? So now as you can see, person 1 get this piece, person 2 get this piece, and person 3 get this piece, and all the pieces have at least one apple. So this is one valid cut. Valid cut. Now we have to find how many different valid cuts are there. So let's say in the second try you cut the pizza from here and then from here, so this is also valid. In the third try you cut the pizza from here, and this is the remaining round. So from this remaining you cut from here middle, so this is also valid. So total 3 valid cuts are there and no further cuts are possible. So yeah, we written here 3 as our answer. Now guys, if you take a look at the second example, here we have apple dot dot, then apple dot, and dot dot dot. So this is this type of matrix we are given. Now k equal to 3, that means we have to make at least 2 cuts. So let's say we make 1 cut from here, then the remaining part is this a apple dot 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 dot, and now from this remaining part we make cut from here. So yeah, this is piece will get to person 1, this will be given to person 2, and the remaining one would be given to person 3. So this is one possible cut. Now if you try to make different cuts such that you will get 3 pieces with each apple, then it is not possible. So let's say you are making 1 cut from here. Okay, so the remaining part is what? Apple dot dot dot. So this is the remaining part. Now if you make a cut from here, then this person 3 won't get any apples, right? So there is no other possible way of making a cut apart from this way. Correct? This is the only one possible way. So here we written 1 as our answer. Thing here is, here k is the 1, k equals to 1, that means we don't have to make any cuts. So yeah, whatever the pizza is there, we have to give to that person only. So since we are not making any cuts, so here we written 1 as our answer. Okay, I hope you guys now understood the question, that what we are trying to do. We are simply trying to cut this given pizza into different possible ways such that each piece has one apple. Okay, so now let me explain you further. So here let's say there was an apple dot dot, apple dot 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 dot. Now here what you did, see, let's say you cut the pizza this way, you cut this pizza this way, then what is the remaining? Apple dot 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 dot. then you cut this pizza this way, then what is remaining? Apple dot dot dot. So this is given to person 1, okay, this is given to person 2, and the remaining this is given to person 3. Now the thing is what, after one cut, see this was the remaining, see this was the remaining part. Now in the remaining part also we have to do the same thing, we have to apply cuts. In the remaining part also what we are doing, we have to apply cuts, okay. And this is what, this is nothing but a sub problem. See, this was the complete problem was this, okay, the complete matrix was a complete problem. Now after making one cut we are getting the sub problem, and sub problem is almost similar to big problem, right? Now so whenever you guys have something like this sub problems, and the sub problem is similar to the big problem, then what we can do, we can write a recursive solution, okay. You can think of this as another way. See, you have choices to make cuts, and there are different choices. See, one choice is either you can make vertical cuts or you can make horizontal cuts. And let's say if there are in vertical cuts that you are doing, so let's say you are from 1 to C column, so you can make anywhere cuts at anywhere at the column 2, column 3, column 4 up till C-1 column. Similarly for the horizontal cut, let's say you have r number of rows, so you can make cut at a row 2, 3, 4 up to r-1 rows. So that means there are multiple ways that you can define a cut, okay. Just let me take this at the bottom. So guys, till now what you have understood, that there are different ways that you can make a cut. You have choices of making a cuts, and now whenever you have choices, then what you can do, you can write a recursive solution. See, whenever you have choices, you can write recursive solution. Got it? Clear till here? Okay. Now after this, what see, again let's come back here. So this was the initial matrix. Now after one cut, what is changing? After you make one cut, what is changing? What are the changing variables that we have to focus? Changing variables. What are they? See, first that is the size of the matrix, that is I and j, row and the column. And second thing is number of cuts, remaining cuts, you can say. Remaining cuts. So there are 3 variables, 1, 2 and 3 variables that are changing here. Then that we need to handle by writing a recursive solution, okay. Got this? So yeah, clear till here? Okay. Now further, one thing, we have to make a note that each piece must contain an apple. So we have to make sure that each piece must contain an apple. So now how we can make sure that each piece must have an apple? So for that, what we can do is, see, one thing is what, after so before cut, what we can do, we can traverse and identify, but this will consume more time. See, every time during every recursion call, we first have to traverse the matrix and identify whether there is an apple or not in the row that we are cutting, on the column where we are cutting. But to avoid this, what we can do, we can build a prefix sum, right? Prefix sum that will tell whether there is an apple in a given, so let's say a prefix of I and j, so this will tell whether there is an apple or not, okay. The count will tell whether the presence of apple, presence less count of apple. So that we have to calculate this only one time, calculate only one time, correct. So we will calculate this prefix sum in order to reduce a time complexity. So yeah, clear till here? So guys, there are 3 changing variables. Let me just summarize this. There are 3 changing variables. There is the number of rows remaining, number of columns remaining, and the number of cuts remaining. Second thing is, we have to make sure that each piece must contain one apple. Then how we can do this, we can handle this in the best possible way is by taking a prefix sum. So prefix sum of ij will contain the count of the number of apple, correct. Clear till here? So now let's move on to the coding part, where we will understand this in much more detail. So the code for this is simple. See guys, here first we took the size m and n. Then we took the vector dp of size this dp of k, then number of rows, and then number of columns. We took this type of dp. Then we took this prefix sum that I have told you earlier. Okay, so then we calculated this prefix sum. So this is the particular formula of a prefix sum that you might know. That is the number of apples in a given row and a column that will be taken by this for prefix sum formula. So this is the standard way of calculating prefix sum in 2D matrix. So this is a prerequisite knowledge that you must have. And then we simply call the solve function, where we pass the size of the matrix, the number of cuts we have to make, the current I and j index, dp, and prefix sum. Now in this solve function is also pretty much simple. So this is the base condition or terminating condition. That means that if there are no apples here, then return 0, because there is cuts are not possible, no possible cuts. Because if there are no apples, then in the remaining matrix, if there are no apples, then there are no possible cuts. Now if k equals to 0, that means all cuts are done. So all the cuts are done, then we return what? 1. Then we simply return 1. We got one possible answer. This is one, you can say, valid answer. Now further we check if the sub problem is already calculated. If the sub problem, that is a dp of k r is already calculated, then we return that answer. Now this is the simple thing. Here first we are initializing our answer. Now what is the number of possible cuts that we are taking? That is from current row is r. So from r plus 1 up till m we are checking. So this is what we are checking. If the prefix sum of rc minus prefix sum of this current row, that is nr and c, is greater than 0, that means there is an apple present, right? There is an apple present between these. So let's say if this is the matrix here, and if this is the nr, okay, and this is r. So if subtracting this is greater than 0, that means then there is an apple present in here. So we can make a cut. Got it? This is this condition. So if this is possible, then we will try again call for this recursive solution. We will make this cut. So our row will change, variable row will change to nr, and we will call for recursive solution, recursive function. And the same thing goes for the column. So let's say if you have cut from here, and this condition will check whether there is an apple or not after in the cut, right? And if there is an apple, then we again call for this recursive function. So yeah, this is the way that we are checking for all the different possible cuts in the rows and all the different possible cuts in the columns for the answer, and at the end we are taking the modulus. So yeah, and here we are simply storing our optimal solution or the best possible solution that is present in the answer into this dp. Got it? Every time we are doing answer plus equal to, so we are adding the number of answers only. This is where we add the number of ways. Got it? So yeah, I hope you guys now understood the coding part as well. Now talking about the time and space complexity. So the time complexity here is m into n into k. See, these three are variables already there. These three variables are already there here. Into what? This is one thing. Into m plus n. Why this? Because here we are taking this for loop, correct? So this for loop will run for m, and this for loop will run for n. So this would be additional time complexity that would be multiplied. Now talking about the space complexity. So guys, here the space complexity would be also m into n into k. You can clearly see the size of our dp array. So this is our dp array, and that same size would be our space complexity. So yeah, that's all for this video. I hope you guys understood the intuition of how we are building the intuition of recursive solution, and yeah, based on that intuition we derived our codings. So yeah, that's all for this video. If you guys have any doubts, then do let me know in the comment section. Make sure you like this video and subscribe to our channel. Thank you.